Let's learn about trigonometric ratios. Trigonometric ratios. A ratio is a comparison of two numbers. For example, boys to girls, cats to dogs, right to wrong. In trigonometry, the comparison is between sides of a triangle. In trigonometry, the ratio we are talking about is the comparison of the sides of a right triangle. Two things must be understood. The side opposite to the right angle in a right-angled triangle is always the hypotenuse. This is 90 degree. A triangle is called a right-angled triangle if and only if one of its angle has a measure of 90 degrees. We will refer to the sides in terms of their proximity to the angle. If we look at angle A, there is one side that is adjacent to it and the other side is opposite from it, and of course we have the hypotenuse. If we look at angle B, there is one side that is adjacent to it and the other side is opposite from it, and of course we have the hypotenuse. One more thing. Theta. This is the symbol for an unknown angle measure. Don't let it scare you. It's like X. Except for angle measure, it's a way for us to keep our variables understandable and organized. A trigonometric ratio is a ratio of the lengths of two sides of a right triangle. The word trigonometry is derived from the ancient Greek language and means measurement of triangles. The three basic trigonometric ratios are sine, cosine, and tangent, which are abbreviated as sine, cos, and tan respectively. Let triangle ABC be a right triangle. The sine, the cosine, and the tangent of the acute angle A are defined as follows. Let's observe the following. Let's practice. Write the ratio for sine A. Sine A is equal to A by C. Write the ratio for cos A. Cos A is equal to B by C. Write the ratio for tan A. Tan A is equal to A by B. Let's switch angles. Find the sine, cos and tan for angle B. Sine B is equal to B by C. Cos B is equal to A by C. Tan A is equal to B by A. Let's observe the following example. Finding trigonometric ratios. Compare the sine, the cosine, and the tangent ratios for angle A in each of the following triangle. By the SSS similarity theorem, the triangles are similar. Their corresponding sides are in proportion, which implies that the trigonometric ratios for angle A in each triangle are the same. Let's observe the following table. Find the sine, the cosine and the tangent of the indicated angle. Let's observe the following table. Find the sine, the cosine and the tangent of 45 degree. Let's observe the following table. Find the sine, the cosine and the tangent of 30 degree. Let's observe the following table. All 45 degree minus 45 degree minus 90 degree triangles are similar. All 30 degree minus 60 degree minus 90 degree triangles are similar. The tangent ratio. If two triangles are similar, then it is also true that A by B is equal to A dash by B dash. The ratio A by B is called the tangent ratio for angle theta. Naming sides of right triangles. The tangent ratio. There are a total of 6 ratios that can be made with the 3 sides. Each has a specific name. The 6 trigonometric ratios. The SOHCAHTOA model. Let's observe the following. The 6 trigonometric ratios. The cosecant, secant and cotangent of theta are the reciprocals of the sine, cosine and tangent of theta. Let's observe the following. Solving a problem with the tangent ratio. We know the angle and the side adjacent to 60 degree. We want to know the opposite side. Use the tangent ratio. Let's observe the following. using trigonometric ratios in real life. Suppose you stand and look up at a point in the distance. Maybe you are looking up at the top of a tree. The angle that your line of sight makes with a line drawn horizontally is called the angle of elevation. Indirect measurement. You are measuring the height of a Sitka spruce tree in Alaska. You stand 45 feet from the base of the tree. You measure the angle of elevation from a point on the ground to the top of the tree to be 59 degrees. To estimate the height of the tree, you can write a trigonometric ratio that involves the height h and the known length of 45 feet. Let's observe the following. Estimating distance. The escalator at the Ames Metro Rail Station in New Delhi rises 76 feet at a 30-degree angle. To find the distance d a person travels on the escalator stairs, you can write a trigonometric ratio that involves the hypotenuse and the known leg of 76 feet. Let's observe the following.